All right, let's walk through a few applications and see what transport layer services they're using. First is email. Second, remote terminal access. So these are remote logging. So if you use PuTTY or use a Mac terminal to try to log into the workstation for the PAs, yeah, that's what the remote terminal access application is. So one could have multiple implementations of the remote logging service. And then World Wide Web, we know lots of web browsers. And file transfer, we have FileZilla as one example, and one can find many other file transfer clients. So each of these is an application. Now, most of the objects they're trying to transfer are text-based. So it's no surprise you see they use TCP. Now, the middle part here is just to tell you what application layer protocols you're using to support the operations of the applications. So SMTP here supports email. Telnet here supports remote logging. HTTP is the application layer protocol for web transfer. And FTP, capital F, capital P, capital P, T, capital P there is to support file transfer. Now, each protocol is defined as an open standard. So the document for it is RFC. So you see here a code for each of the protocols. So RFC 2616 is the document for web. Don't be surprised. If you Google it up, you see that there are 176 pages of it. Yeah, now some of you may begin to worry because in the second half of the semester, you'll be implementing a very simple web server. Yeah, and the reason that I'm saying that you are implementing a very simple web server is because of this exactly. Yeah, we cannot be implementing the complete web server. All right, so those are the easy applications, commonly used applications. We have two more commonly used applications. So this is streaming multimedia, such as YouTube. This is internet telephony, such as Skype. Now, they are audio video, so it's no surprise. Again, you see them using UDP as the underlying transport protocol. But some of them use TCP these days, and actually there are more and more of them using TCP, which I will describe in a little bit. So, YouTube, for example, uses UDP as the underlying application layer protocol, such as web is doing. And because HTTP is using TCP as the underlying transport protocol, that means YouTube as a streaming service is using TCP as the transport layer service. Now, Skype as an internet telephony application, it actually uses both UDP first. So what it does is to try to call to the receiver using a UDP connection. In the earlier years, this has been working fine, but gradually the Skype engineers discovered that more and more of these call requests got blocked. So they never really get through. And they discovered that the reason is this. The antivirus softwares now we're using, they sometimes have a very interesting default firewall setting, which is to block UDP traffic entirely. And this is because many of the denial of service attack, because they want to not bother setting up TCP connections and just send a bunch of these UDP packets to flood a particular service. So lots of these antivirus softwares have this default firewall setting, blocking all UDP traffic. Now, because of that, when Skype discover a call initiation is blocked, meaning not responding, then Skype would turn to send the call request using TCP. And that's why UDP uses also just HTTP over TCP. This is because the firewalls never block port 80, which is the default port for World Wide Web, because hey, we will all at least need web access. All right. Complicated, isn't it? The reason that we're choosing a transport layer service ended up being more non-technical. Yeah, because there's security concern, therefore firewalls gets really strict over blocking things. Therefore, multimedia services will have to get around the problem using TCP and suffer from the problem that we have higher initial delay because we need to set up TCP connection. There's a call setup delay, a connection setup delay. Yeah, unfortunate, but that's the way it is. And next is quiz.